Bo from MrBoEnglish.com, and recently we've been working on the quadratics unit in Con Algebra 1 course, and this is the factored form lessons, and this is the last practice for the factored form lessons, which is word problems, and we are going to remind you that we're talking about parabolas, and parabolas can open up or open down. Today we're going to be doing a lot of down, and they always have points where they cross the x-axis called the x-intercepts, and their lowest point if it opens up, or their highest point if it opens down, is called a vertex. And the line that runs straight down the middle from the vertex, vertical line, is called axis of symmetry. Some symmetry. Okay, there we go. All right, so let's look at our first problem. A hovercraft takes off from a platform. Your problems will not be the same as these. Okay. Its height in meters, x seconds after takeoff, is modeled by this h function, h of x. And the question is, what is the height of the hovercraft at the time of takeoff? Hovercraft, for my Thai students, that is something like a little bit like a helicopter or an airplane. It flies in the air, but it flies very, very close to the ground. It doesn't fly very high. Height means how high, kwamสูง, right? So we have x, and x is seconds, and we have h of x, which tells us what? The height. So we have a little platform, like a stage, and we have our hovercraft here, and our hovercraft takes off and then goes down, and when it hits the ground, it's at zero height. So we could do these kinds of questions, ask for a lot of things, like what time when it hits the ground, okay, how high can it go. Alright, but this doesn't ask for any of those. It asks what's the height of the hovercraft at the time of takeoff. So this is the height, okay, h of 0. So at 0 time, what is the height? And if we continue our parabola down here, it goes into -1 time, but we're not interested in that. So we're going to find h of 0. So h of 0 at the time of takeoff is equal to -0 minus 11, and we'll just put 0 wherever we see x, okay? 0 plus 3, we're just substituting, which is negative times -11 times 3, which is 33. Remember, negative times negative is positive, so it's 33. So it starts off at 33 meters. Let's look at another one. Anna dives into a pool off a springboard high dive. Her height in meters above the water, x seconds after diving, is modeled by blah blah blah. How many seconds after diving will Anna hit the water? So we have a diver, and here's the diving board, and here's our diver, and they're going to dive off and go into the water. So it can ask us lots of things. The last one asked us how high at 0 time. So this is at 0 time. Or it could be how high does she get? Or in this one they ask how many seconds after diving will Anna hit the water. So they want to know about this point here. She hits the water at what time? How far along? Okay, and this is what? This is the x-intercept. This is our x-intercept. So we're going to find one of the x-intercepts. So we're going to set h of x as equal to 0. The height is 0. Negative 5 x plus 1 times x minus 3. So that is equal to, and 0 is, this x plus 1 has to be 0, excuse me. X plus 1 has to equal 0, or x minus 3 has to equal 0. So x is either equal to negative 1, excuse me, x is equal to negative 1, or x is equal to 3. So our negative 1 time is back over here before she jumps, so it's not that one. Okay, it's not the negative 1 time because that's before she jumps. It's after she jumps, and after she jumps it's x equals 3. So how many seconds after? 3 seconds after. Let's look at the next one. Guillermo is a professional deep water free diver. His altitude in meters relative to sea level x seconds after diving is modeled by this function g. And what is the lowest altitude Guillermo will reach? All right, so let's draw it out. Here's our water, and Guillermo is a diver, so Guillermo is going to dive down and then come back up. So he could ask us lots of things, like what time does he come up, or how deep is it? And this is the question it's asking, is how deep is it? So it wants to know our vertex. So we have to solve for the vertex. Okay? And we did that before in some other videos. So first of all, we need to find the x-intercepts. So let's start with that. So we're gonna set g of x is equal to 0. Alright, so now I know x is equal to 0, or x minus 100 is equal to 0. For this one, x equals 100. So here I have 0, and here I have 100. And the axis of symmetry is going to go right down the middle there. And what's the average for that? It's 100 plus 0 divided by 2 is equal to 50. So our axis of symmetry is right at 50. And we really want to know how deep it is at 50. So we're going to find, this is a G, not an H. What's the altitude at a time of 50? So that's 1 over 20 times 50 times negative 50. And 50 times negative 50 is negative 2,500. And 1 over 20 is equal to negative 125. Okay, so our lowest altitude is negative 125. Alright, we're going to do one more together. Simon has 160 meters of fencing. To build a rectangular garden. So he's going to build a garden, and the garden is going to be have a fence, and the fence is 160 meters long. So what do I know? I know the perimeter all the way around is 160 meters. And if I have some width here and width here, then I know that these two sides are equal, so this is going to be 80 minus W, but they've done it a little bit differently here. Oops. And over here is also W minus 80. So our area is negative W times W minus 80, okay? So they want to know what width will produce the maximum garden area. So if we have this area function for width is equal to negative W times W minus 80. I can see this is W squared, so it's going to be a parabola, and it's negative, so it's going to look like that. And I'm looking for the maximum point. So what is the maximum point? The maximum point is the vertex. Okay? So we're going to find the zeros first. We're going to find our zeros first. So I know W equals 0, or W minus 80 is equal to 0, or W is equal to 80. So over here I have 80, and over here I have 0. So at 80, the area is 0, and at a width of 0, the area is 0. And why is that? That's because if we have a width of 0, whoops, we just have a line. We have one line with two sides. So really it's just one line with a width of 0, and it has two sides, and each side is 80, but the area here is 0. And if we have a width of 80, we have a width of 80 on two sides, and then we have this other dimension, which I guess I call length here, as 0. And then our area there is 0 too. 0 times 80 is 0, and 0 times 80 is 0. So somewhere in the middle, directly in the middle, okay, I want to know where this axis of symmetry is. 80 plus 0 divided by 2 is equal to 40. So the axis of symmetry is at 40, and the vertex, where is the vertex? So let's plug in and get the area for 40 is equal to negative 40 times 40 minus 80. 40 minus 80. Negative 40 times negative 40, which is equal to 1600. So our maximum garden area is 1600, but that's not our answer. Answer is what width will produce the maximum garden area, and that width is 40. And the reason for that is if we have a rectangle with some kind of perimeter, the biggest area comes out from being a square. So if you ever have this kind of question, and you have some perimeter, some fence or some string or something that goes around, and you want to make a rectangle, the biggest area is always when it's a square. So those are the word problems for Khan. I hope that helped you, and if you need any extra help from us, please contact us online. Mr. Bo English รับสอนนักเรียนตั้งแต่ป .3 ขึ้นไปทางอินเทอร์เน็ตในสไตล์ EP ครับผู้สนใจช่วยติดต่อครูแจงหรือไปเว็บไซต์ที่ www.mrboenglish.com